videos on agent design pattern. We saw React agent and we implemented an end-to-end React agent. We did some hands-on to implement it in raw Python and also in LangGraph. And then we moved on to reflection agents and we implemented them in LangGraph again. And then we implemented a simple chatbot with tool use and we implemented that in LangGraph. So in this video, let's move on to plan and execute. Let's see what plan and execute is, and we'll implement it in LangGraph and see it in action. So let's get started. So what exactly is plan and execute? So this figure here gives an idea of what plan and execute is. So basically it was introduced in this paper titled Plan and Solve Prompting. So pretty much plan and execute is inspired by this paper, and this was around 2023. So if you take the chain of thought, which was a normal thing at that time, we used to tell the LLM, let's think step by step in the prompt, and the LLM proceeds to think step by step and then gives you a better answer. But this seems to be failing with three types of errors. Mainly it's the missing step error. And so this work proposed plan and solve prompting, and they have introduced two components, which is that devising a plan to divide the entire task into smaller subtasks and then carrying out the subtask according to the plan. So at a high level, we have the user who's going to interact with the system, and the agent starts by planning what needs to be done in order to address the user's query. As a first step, the agent is going to generate tasks or break down the query into different tasks or list of tasks, and then it lists them like this. And it starts by executing one task at a time, and it's executed by a single task agent. It's going to go through a loop, for example, maybe using a tool or even without using a tool, and then it updates the state with the task result, and then it does some replanning. The replanning could involve adding more tasks to the list, and this loop continues on and on. Eventually, when the agent is exhausted with all the list of tasks to be done, it returns to the user and says, I'm done, and then it responds to the user. That's plan and execute at a very high level. Now let's get our hands dirty and implement it in LangGraph. So let's start by launching Jupyter Lab. Let me create a new notebook, and I'm going to start with installation. So I'm going to do pip install LangGraph. We need LangGraph, of course. We need LangChain community. We need LangChain OpenAI. Obviously, we are going to be using the OpenAI models as our LLM, and we need Tavily Python. We're going to be using Tavily for the web search. So let's use the Python package from them. So I'm going to run it for installation. So everything seems to have gone through fine, and most of them are already installed in my virtual environment anyways. So once we get that, I'm going to do other setting up stuff like environment variables and stuff. So I'm going to say, so all this code is just to get the OpenAI API key and Tavily API key. So let's run that. It's asking for the OpenAI API key. So I've set the API keys now. So hopefully in terms of the settings, we are sorted. So with the settings out of the way, let's look into how we will go about implementing this, or how the LangGraph will look. Basically, we will have the planner, which is going to be implemented separately, and the flow is going to flow into an agent. This is going to be our main agent, which is going to be the execution agent. And the planner is going to do a to-do list that is going to be fed into the agent. And we're also going to implement a replan, which is going to redo the to-do list that is going to be fed back into the agent. And so in terms of the implementation, we need to implement the planner, we need to implement this agent, and we need to implement this replan. So let's go ahead and implement each of them. And we also need to implement this tool, which is going to be the Tavily tool, which is going to be used for fetching the data from the internet. So let's do that as well. So we are going to be implementing a tool, which is going to be the Tavily browser, and we're going to implement the execution agent, the planner, the replanner, and finally we are going to build the graph for the agent. So let's start with the tool. So let's define the tools. It's going to be a list. So I'm going to create a list. List is going to be Tavily search results of the, let's say max results is 2. But I haven't imported this Tavily search results. So I'm going to do from LangChain community.tools.Tavily stabili search import. So that's run fine. So we have got the tool. We execute that. So we have created the tool now. And let's now go ahead and implement the execution. So for that, we need the from LangChain OpenAI, we need the chat OpenAI, and from LangGraph.prebuild, we need the create React agent. So we are going to be using a React agent, as I mentioned here, and we're not going to be implementing this from the scratch because we are interested more in simply using it. Plus, I've done a separate video on how to implement the React agent. So let's just go ahead and use that straight away. So let's see if the import goes through fine. So we have imported both of them. All that we now have to do is define the LLM, which is going to be chat OpenAI, of model, which is going to be GPT-4 Turbo Preview, and the prompt is you are a helpful assistant, and agent executor is going to be create React agent. I'm just going to simply create the React agent and say pass the LLM, the tools, and the prompt is going to be the one that we just defined. So we have created the execution agent. Now we can move on to the planning agent. So for the planning agent, we need to first define the state. There are some standard imports that we need to do. So let's import the operator from typing, import annotated, list tuple, and from typing extensions, import type dict. So that's there. We got the imports fine. Now we can define the state as to, class plan, which extends from the base model from Pydantic, and we're going to say steps, which is going to be a list of string. So these are the different steps. Obviously, the planning task is going to have a list of string. So we're going to say description is different steps to follow, should be sorted. Okay, so we haven't imported the base model, so it needs to come from Pydantic. From Pydantic, import base model, comma field. So that's fine. We have defined the state for the planner. Now we need to define the planner itself. First, let's define the planner prompt, which is that of chat prompt template from messages, and we are going to pass a list of messages. And the system message is going to be that of this, and there's going to be a placeholder, and the placeholder is for the actual message that the agent usually takes. And we have to create the planner, because we're going to create the model, which is going to be the GPT-4o, and the temperature is 0 with structured output of the plan. So basically we are passing the plan to the model, and the output of the model is passed to the prompt, the planner prompt. We haven't imported this chat prompt template, so if we import that, it's going to work. From LangChain core.prompts import, you can see that ran fine. And now we need to implement the Replanner. Before we do that, we forgot to do the system prompt. So I've given the system prompt here. Basically, for a given objective, come up with a step-by-step plan. This plan should involve individual tasks that, if executed correctly, will yield the correct answer. Do not add any superfluous steps. The result of the final step should be the final answer. Make sure that each step has all the information needed. Do not skip steps. So let's run that. So that's the planner. Now, if we are curious, it's better to test the planner as well. So let's quickly test the planner. So planner.invoke. We're going to invoke the planner with the message, close that bracket. And let's say the messages is going to be a list of users. So in the message, the user is going to say, what is the hometown of the best cricketer ever lived? Let's see what it says. Right, this is going to be a comma because it's a list. So I've separated it by a comma. Now, if we run that, hopefully we'll get an answer. So it is broken down, we can see, into different steps. The first step is to identify the cricketer widely regarded as the best ever. This is subjective, but Sir Donald Bradman is often considered the greatest cricketer of all times. And the next plan is to research the hometown of Donald Bradman. So we can see that it's breaking down into different plans. So the planner is working fine. So we can now move on to the replanner. So we now need to define what message it takes. So class response inherits from the base model. We're going to say response is a string, so that's how much it's going to take. And we're going to say act, once again, base model. And we're going to say action is the union of response, and the plan, which is a field, and the description of the field is that action to perform. If you want to respond to the user, use response, and if you need to further use tools to get the answer, use plan. So we haven't imported this union, so I'm just going to import it here. Where is it? It's here somewhere. So I'm just going to say from typing import union. So that's sorted. Now I'm going to say, basically we're given two choices, whether it can either do a response or it can go back to planning, because it's a replanning class. So once we have defined that, now we need to give the prompt. Replanner prompt is chat prompt template. From template, we're just going to use a template for it, and we're going to obviously give a long one. So I'm just going to, before I type in that, let me type the rest of the code. So replanner is that of the chat OpenAI, which is the model we are passing, and the model is the GPT-4o, and the temperature is 0 with structured output of act. So the output of this one is going to be fed into the replanner prompt. So that is the chain that we are creating. Obviously, we need to give the replanner the template. So I'm just going to give the template here. And the template we are going to be giving is, so this is the template we are given. For the given objective, come up with a simple step-by-step plan. The plan should involve individual tasks that, if executed correctly, will yield the correct answer. Do not add any superfluous steps. Basically, it's the same one as before, but your objective was this. Your original plan was this, which is the plan. Your objective was the initial input that we gave, but the interim plan was this one. You have currently done the following steps, and we're going to provide the past steps. So we need to provide 3 input to this one. Update the plan accordingly. So we're literally saying that you have to update the plan based on these parameters. If no more steps are needed and you can return to the user, then respond with that. Otherwise, fill out the plan. Only add steps to the plan that still need to be done. Do not return previously done steps as part of the plan. Right, so let's run this. That seems to run fine. And now is the time to create the graph. Before we write any state graph, we generally need to define the state. Let's start by defining the state. This is going to be a markdown, and we're going to class execute is type thick. It's a standard format. So we're going to have an input, which is going to be the string. We are going to have a plan, which is going to be a list of strings, and we're also going to have replan. Well, past steps, we're going to have past steps, which is going to be annotated with a list of tuple. It's going to be added basically, and the response is going to be that of a string. So I've explained previously why we annotate here in my previous videos to do with implementing one of the design patterns. I've explained why we actually need to annotate here and what purpose it serves. So I'm not going to go through that again. Now that we have defined the plan execute, we need to now move on to actually implementing the graph. So let's define the workflow. The workflow is the state graph, or we haven't imported the state graph. So I'm going to import that here. We're going to say from LangGraph.graph import state graph, start and end. So those are the standard inputs we need when we are building the graph. So now if I say state graph, it's going to take the plan execute. That's the data structure that's going to be shared by all the nodes. Now, if we go back to the graph that we just discussed, we can see that we have 3 nodes. One is the planner node, one is the agent node, and the next one is the replanner. So we need to define these 3 nodes for the graph. Let's start by defining them. Workflow.add node of planner is going to be the plan step. Workflow of add node, the agent, which is going to be the execute step. Add node of replan, which is going to be the replan step. So those are the 3 main things. We have defined nodes now for those 3 things. Now we need to define the edges. Add edge. From the start, we are going to be connecting to the planner, and from the planner, we are going to be connecting to the agent, and from the agent, we are going to be connecting to the replan. And we go back and have a look. This loop is going to be a conditional loop. So the agent is going to either decide to use the tool or is going to end and replan. So this is going to be something conditional. We need to say that. So we are going to say that workflow.add conditional edges replan and should end. I'll tell you, we need to, this is a function, so we need to implement this function as to say when that actually should end. Otherwise, we need to go to the agent and end. So that's the condition that we need to have. So the condition is mainly for the replan node. The replan node should decide whether it should end or it should go back to the agent. That's what we are saying here. So the replan node should decide to end or it needs to go back to the agent. So that's what exactly we define that as the conditional edge. So app is the workflow that's compiled. .compile. Right, it says state graph is not defined. Why? Because I did not run the import. Now if I come back and run this, plan step is not defined. Right, so we need to define plan step, execute step, and replan step. So let's define those now. So define plan step, execute step, and replan step. So let's define that. Plan step is going to take the state, which is nothing but the plan execute, and plan is to avoid, basically we're going to make it asynchronous. So I'm just going to say async. Now we need to use await here. So I'm just going to say planner dot now asynchronous invoke, and I'm going to say pass the message. The message is these messages defined as, which is a list, the user message, state of input. So we're passing the input here, closing the bracket. It's better to do like this, message, and we are going to return the plan, which is the plan.steps. Similarly, we need to define the other ones, async, define, execute. Let's finish the replan step, which is easier. So it's also going to take the state, which is going to be which is of type plan execute, and the output is await of replanner dot invoke, well, a invoke of the state. And if the output dot action is of type response, we need to do something. So I'm going to say is instance of output.action.response. Then I need to return the response output.action.response. Else I need to return the plan. So basically we need to decide between responding or planning. So that's what I'm trying to do here. Output.actions.steps. So steps is basically the plan. As you can see, when the plan, we are returning the steps. So here we need to return the action.steps. Now is the actual workhorse, which is going to be the real agent. So define the execute step. It's also going to take the state, which is the plan execute, and I'm going to say plan instead of the plan from the state, and the plan we convert that to string. So we are going to basically list them as numbers. So I'm just going to say app string of I plus 1 step, or I comma step in enumerate the plan. Basically we are converting the plan into a numbered list of steps. That's everything needs to be string. So that's what we are trying to do. And the task is that of plan of 0. So the highest one in the list is basically the plan. That's why we're taking plan of 0. Meanwhile, I seem to have forgotten backslash. Okay, that makes sense now, hopefully. No, so for step, I need to close that. Now it makes sense. Plan of 0. Task. So the formatted task now is for the following plan. So this is the plan. You are tasked with executing step. It's going to be the first step. You're going to be executing this task, and we're going to say the agent response for that is await the agent executor.a invoke. I'm going to pass that as a message because it's going to take only messages, and it needs to be in a dictionary. So messages colon a list. I'm going to pass it as a list, and we're going to say what the user message is, that of task formatted. I'm going to close that, and we're going to return another dictionary, which is past steps colon task comma agent response messages of -1, basically the last message, the content of the last message. So that's what we want. That's about it, I guess. So we have defined the execute step, we defined the replan step, we have defined the plan step. So let's run that. I'm sure there must be errors. So closing parenthesis does not match the opening parenthesis. Interesting. I'm going to move all these three functions to a separate block so that I can debug it easily. So I'm just going to move it here. You can see already that the problem has become easier now. It's line 4, which is in plan step. So this needs to be in an opening bracket. Now will hopefully be sufficient. Right, so we haven't defined the should end condition here, which is again a function. So I'm going to add that along with the rest of the steps. So I'm just going to say define should end, which is going to be a condition, but it's going to take the state. And I'm just going to say if the response, if there's a response in state and the state of return end, else return agent. So we have executed that and should end is now there. Now if I run this, it all went fine and we have compiled. Let's now go ahead and display the graph. Obviously we need the ipython.display import image dot display, and I'm going to say display the image app dot get graph of the true.draw mermaid png, and we can see that we have the planner, we have the agent, we have the replan, which takes us back to the agent. Otherwise the replan takes us to the end. That is exactly what we want, and we have achieved that graph. Now that the graph is ready, we can set some input and we can kind of invoke it. So let's set a config. Because this is going to be a recursive call to the LLM, we need to define a limit as to how many calls we can have. Otherwise, if it turns out to be infinite call, then it's going to cost us a lot. So the inputs are going to be the input of what is the question that we can ask. So I'm going to ask, what is the hometown of the best cricketer has ever lived, right? So I'm going to ask that as input. Now let's loop for the event in app.astream. Basically, we are streaming the inputs and the config is the config. We are going to say for key comma value in event.items. If key is not equal to n, basically if we are not ending, then we are going to be continuing to print the value which in the event. And let's see what happens now. So that has started and we can see that that is the plan that it has got. It's basically identify the cricketer widely regarded as the best cricketer that has ever lived. And then the second step is to research the birthplace or hometown of Sir Donald Bradman. And the third step is to find a specific town or city where he was born or raised, verify the information to ensure accuracy, conclude with the name of the hometown of Sir Donald Bradman. So that seems to be running and we have got the response. The plan has been successfully completed based on the research conducted. Sir Donald Bradman, widely regarded as the best cricketer that has ever lived, was born in New South Wales, Australia. Final answer, Bowral, New South Wales, Australia. That's just bang on. So that is all that I wanted to show you today. We basically saw about plan and execute, and we got an input from the user and we implemented these three nodes: plan, replan, and this one in an agent and this agent. And we controlled this flow. Basically, this flow is a loop and we implemented using conditional loop in LangGraph. And eventually we printed it and we saw that this is the graph that we are getting. And we also tested it by passing a prompt and we got a beautiful answer or a response, which was just bang on. Now you may be wondering if I have written all this. Basically, this is pretty much the plan and execute example that they have given for LangGraph. So if you want to go through the notebook, it is available in the LangGraph documentation. Otherwise, I will also be committing the code to one of my repositories, which I will share in the description. I'm signing off and I will see you in my next video. Take care.